The second part of 6.4, which is also the last portion for notes in Chapter 6a, has us working with inverses simply by writing equations. The steps for writing equations for exponential and logarithmic functions are as follows. We have 4 steps to follow, and they're very similar to when we wrote inverse functions for linear equations earlier this semester. Step 1, if you have function notation like f of x or g of x, replace that with y equals. Step 2, we switch x and y around. Step 3 is normally where we'd get stuck with these functions. We really can't get y by itself until we loop it to change forms. Meaning if we have an exponential function, we'll change it to logarithmic as its inverse. And if we have logarithmic, it'll become exponential for the inverse. Once you loop forms, you do need to solve for y, get y by itself. Finally, rewrite your answer in inverse notation. Let's take a look at a couple of examples on the right. Write the equation for the inverse of the function. Example A, f of x equals 10 to the x minus 1. The first thing we're going to do is just rewrite the function as y equals 10 to the x plus 1. The second step, we just switch x and y. And then the third step, technically, is solve for y. However, we get stuck because y is the exponent. What we need to do is loop it to change forms. In steps 1 and 2, it's exponential. That means in step 3, we need to make it logarithmic. We start off simply by writing the word log, L-O-G. The base is 10. I'm going to write that now, but because it's base 10, we don't need that in our final answer. If it was a different number base, we'd have to include it. And now we loop. We're taking the log of x, and that's going to equal y plus 1. Once you loop it, get y by itself. Well, now we're just going to subtract 1. Here's where we need to be careful. If we have log base 10, that just means x. And then we minus 1. Notice that minus 1 does not go in parentheses. So I'm just going to put I already have a star. Wow. I'm just going to put another star or another note underneath it. The negative 1 is not in parentheses. There'll be some cases where it needs to be, but this is an example where it's not. That means the function will move down 1, not to the right 1. Just something to think about. Parentheses are very significant in this process. Last but not least, step 4, we write in inverse notation. Remember, our initial function was f of x. That means we need to have f inverse of x. And it's going to be log of x, because that defaults to base 10, minus 1. And that's all you do. That's how you rewrite the form, creating its inverse. Example B, g of x equals log base 7 of x plus 5. Notice this example is log, but these rules will work for ln as well. Just so you're aware, anything that's a logarithm would follow this template. Again, here we go. Step 1. Since our function notation is g of x, we're going to simply replace that with y equals. And then step 2, replace or switch x and y. And here's what we need to be mindful of in this step. We can't move 5 over because it's in parentheses. Again, those parentheses are very, very significant. That means we actually have to loop first before the parentheses eliminate. This is a logarithmic function. That means its inverse is exponential. We need to know our base, and our base is 7. What I'm going to do then is start with 7, and I loop it for the exponent, 7 to the x power. That's going to equal y plus 5. And now that it's just y plus 5 and no logarithm, the parenthesis can go away. But it couldn't go away until this step. From here, it's pretty straightforward. To get y by itself, I'm going to subtract 5. Thinking of like terms, if we have an exponent, oops, I wrote 5, wow. If we have an exponent like x and we subtract 5 from it, they're not like terms. That means 7 to the x minus 5 is going to be our inverse equation. To write it as an inverse function, though, we need that function notation. Step 4 then, g inverse of x is 7 to the x minus 5. And those are the steps to follow to create one form as an inverse of the other one. And that's where we'll call it for 6.4. You can cross off that example at the bottom. Your assignment today will be to complete the 6.4 Pearson on Pearson Realize.